Hi, my name is Haowei Lu. This is my probability homework 3, problem 1. For the problem 1, we need to find P, the probability of x equal to k represents a mass function, and also to calculate the mean of x and the mean of x squared, and find the conditional probability mass function of this one. So for the question A, we have this general geometric progression equation, and according to this we get the sigma k equal to 0 to infinity, a is equal to 1 over 1 minus p. When k equal to infinity, this minus p to the k is equal to 0, so this is equal to 1 minus p2. So then we get the sigma k equal to 0 to infinity, a multiplied by p to the k is equal to 1 minus p, a over 1 minus p. So for this equation, we differentiating both sides with respect to p. So for the left side, we get this part, and for the right side, we respect to p, we get this part. And since we need to let the left part is equal to a math function, which means that the right part which is equal to the left should be equal to 1. So in this way, it is equal to 1 minus p to the square, and which is 4 over 9. And so then, for the question problem B, we need to calculate the mean x, the mean of x. So first, we get this part equation from here. We differentiate again both sides with respect to p, so we then get a multiplied by k to the square and multiplied by p to the k minus 1 equal to the right part differentiating respect to p, which is like this. So for here, we know that a is equal to 1 minus p to the square. So we put a equal to this, and we can. So here is missing. So it's 1 plus p over 1 minus p. Actually, this part is the mean of x according to definition, right? The mean of x is equal to k multiplied by the probability of x equal to k, which means that a multiplied by k to the square multiplied by the p to the k minus 1, which is equal to 1 plus p over 1 minus p. So p is equal to 1/3. Then we get the mean of x equal to 2. Similarly, we can calculate according to definition, the mean of x squared equal to k to the square multiplied by p x equal to k, which is k to the third, k to the 3, and multiplied by a multiplied by p over the minus 2. So similarly, we differentiate that equation again with respect to p. So for this part, this equation, we differentiating the equation both sides with respect to p. So for this part, first we should multiply the equation both sides by p. So we make this k minus 1 to the k, right? Multiplied by p. So then we differentiate this equation to get a to the square multiplied by p to the k minus square. So this part is equal to the mean of x squared. This part. So, and also for the right part, we differentiate like p. So 1 minus p over blah 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 blah. And then we get this part is also the same with 1 plus p over 1 minus p. So this is also equal to 2. And for the problem D, so conditional probability. Actually, for the probability of I for the x greater than 1, smaller than 10, we can use the equation, right? This is the sigma k to the 1 to 10, and since a equal to 4 over 9, so this is 4 over 9 to k multiplied by k multiplied by 1/3 to the k minus 1 equal to 1. So for this part, this is 1. Actually, so for this part, so actually for this part, and so since this is one, this equation, so and similarly, okay, don't forget about this. For this part, we know this part probability is equal to 1, so which means this part conditional probability, which we can consider this is as the full set. The full set, which is this part is omega. So the conditional probability, which it should be equal to the probability of x equal to k. So this is so x equal to k should be 4 over 9 multiplied blah blah blah, which is equal to 4k over 3 to the k plus 1. But for this way, k should only equal to 1 to the 10. So we have assumption here that x greater than 1, smaller than 10 is the set, the whole set. That's it, problem 1.